Okay, so here we are. We're on to, I guess this is section 5, and it's about graphing. So we're going to graph these two particular graphs and see how we do. If you missed questions here, to me, performance is a function of preparation. You simply didn't prepare as well as you should have. So I'm going to graph y equals x squared plus 2x minus 3. And to do that, I'm going to use my graphing calculator. So I'm actually going to take a moment to start my graphing calculator up right now. Okay, see how much longer I have to record. Oh, I got plenty of time. I'll get all of this done this period. Very nice. While I'm waiting for this to boot up, I'm just going to have an Oreo here. Hope you're enjoying the Oreos at home. What? You don't have Oreos? Oh, no. All right. Shouldn't talk with your mouth full. I'm validating the software license. Look at this. All right. So, on your graphing calculator, you go to y equals, I'm going to clear this out, x squared. Now, the first thing I want you to realize is that the x squared button is the variable button right here. That's the only button we ever use for variables. So here's my x, and then I have my squared button over on the side here. I think it was plus 2x, right? Pretty sure it's plus 2x. Let me look on the test here. Yep, plus 2x minus 3. Plus 2x minus 3. And I hit graph. Nice looking graph. Came out very good. But we don't want to eyeball things. One kid in the class eyeballed things. We don't want to eyeball them and kind of sketch them. We want to go to the table. And I want to look for the part of the table where things repeat. So if you look here, the zeros repeat, there's symmetry there. The negative 3s repeat, the negative 4 is in the middle, that's good. But I'm looking for something with the 5 and or the 12, particularly the 5. So what I'm going to do is just scroll up one more place. And there's my complete symmetry. The 5s, the zeros, the negative 3s, etc. And I'm going to copy that table down. Negative 4, 5 is what I start with. So let's go over here, and I will copy down my table. X, Y. Negative 4, 5. Negative 3 was 0. Negative 2 was negative 3. Negative 3 was negative 4. Negative 4, negative 3, negative 2 is negative 1, I'm sorry. 0 was negative 3. 1 was 0. And 2 was 5. So I'm going to plot these points now, and I'm going to get negative 4, 1, 2, 3, 4, 1, 2, 3, 4, 5. There's my point. Then I go negative 3, 0, and then I go to 2, negative 3, 1, negative 4, and here, and here, and here, and here is my problem. Now, very few people had difficulty with that on the test. Now comes the fun stuff. The zeros, which just about everybody got right too. Everybody pretty much understood that this point and this point were the zeros. Now you can look them up from the table, whatever pairs up with the zeros, or you can look at them on the graph. This is where x is negative 3 and this is where x is 1. Some people put down the coordinates. You don't put the coordinates. You only put down the values, negative 3 and 1. Now, next is the axis of symmetry. Axis of symmetry is the line that runs right down the middle. There it is. And what we said to you yesterday about the axis of symmetry was, it's a vertical line, so it always begins x equals. And I said, kids always forget to come over here and write x equals. They often forget, not always, but they often forget to write x equals. And they just put the x value. Now, the x is passing through where x is negative 1, so the answer is x equals negative 1. In vertex, the vertex is the turning point. It's the same thing. And that would be the coordinates of this point here, which is negative 1, negative 4, or which are negative 1, negative 4. So that would be how we graph our parabola, each of the pieces. The biggest mistakes, kids forget the x equals with the axis of symmetry. And some kids forgot the coordinates at a turning point, but that was pretty rare. The biggie is forgetting the x equals on the axis of symmetry. Okay, so now let's go to the next part of this graph. We're going to graph y equals 2 to the x over the domain values from negative 2 to 3. And what's done here is now we're going to put a table again, but this time the table is going to be horizontal. And in my graphing calculator, I could actually put in, if you check this out, let's go to the graphing calculator, and I could put in, go to y equals, clear this out, and put in 2 to the x. Remember that caret symbol that I just pressed right here? Oh, we're going to clear that out. Y equals 2, caret symbol, and then x. Oh, let's clear this out again. I'm sorry. I need to go to y equals. Clear, and then 2 caret x. And then I'm going to hit graph. And there is my graph. It's an exponential graph just by looking at it. And let's go to table. And there's my table. Now I wanted the piece that goes from negative 2 to 3, which means I would be looking at this section of the graph down in here. Okay? Now, all of that said, if I want to just see that section, all I need to do is this. I hit the button too many times. This can drive me absolutely crazy. You see how big the exponential function gets here. All right, now we're getting into the numbers I want. There we go, from negative 2 to 3. Oh. From negative 2 to 3. So it's 0.25, 0.5, 1, 2, 4, 8, and so on. Okay? So then I come back over to here, and here's my graph from negative 2 to 3. And I could either plug these in one by one, or I could just look at the table of the graph. 2 to the negative 2 was 0.25. 2 to the negative 1 was 0.5. Positive, I don't know why I put a negative there. This is 1, 2, 4, and 8. And all this means is that 2 squared is 4, 2 cubed is 8, 2 to the 0 is 1, 2 to the negative 2 is 0.25, and so on. And now I just want to graph these particular points. So at negative 2, I'm going to do 0.25. Negative 1, I'm going to do 0.5. 0, I'm going to do 1. 1, I'm going to do 2. 2, I'm going to do 4. 3, I'm going to do 8. And there's my graph, my exponential graph. By and large, kids did really well on that. Some hiccups here and there. Some kids had hiccups in this area of the graph. Just use your calculator, guys. Okay. Next up, though, this part here, average rate of change. Some people forgot it. Some people did it and did it wrong, but we're only going over the interval from 0 to 2. Now, we just did this whole thing about average rate of change, and it's 0 and 2 are the 2 inputs. Let's figure out the output. Well, at 0, the output is 1. At 2, the output is 4. 0, 1, this is the point written vertically. It's the same point written horizontally. Vertically, horizontally. Average rate of change in slope formula, change in y over change in x, 4 minus 1, 2 minus 0, 3 over 2. That is my answer. Okay? So there's the function. There it is graphed. The biggest mistake I saw is there were 2 big mistakes. This, which you should have realized are nothing more than these coordinates. And secondly, that some kids graphed this wrong because they got the wrong values here and here. Just plug it into your calculator and let your calculator do the work. Okay. One more section to do.